All right, so here we're going to be having a look at the laws of indices. We're going to focus on the four most important ones, the most common ones which come up. Now, the laws of indices, we better talk first about what indices are. Indices are powers. So if you remember in BIDMAS, you have BIDMAS, and the I stands for indices because you do things like 2 cubed quite early on in the calculation. This is an index. So we're looking at powers, basically, the laws of powers, you could call it. And there are 4 rules. First one is that if you multiply the same number, and you're multiplying the powers like this, you have 2 to the power of 3 times 2 to the power of 2, your answer is 2 to the power of those two things added together, which in this case would be 2 to the power of 5. So that's the first rule, is that you add the powers together if you're multiplying a number that's to 2 powers. So a second example, if we have, it doesn't have to be a number, it could be a letter. So if I have x to the power of 5 multiplied by x to the power of 7, my answer is going to be x to the power of 5 plus 7, which is x to the power of 12. So there's the first rule. Now the second rule is pretty much the exact opposite, where we're dividing. So if we take 3 to the power of 5, and I want to divide it by 3 to the power of 1, which is just 3. I didn't have to put the 1 there because 3 to the power of 1 is just 3. If we're dividing, we subtract. So rule 1, if you're timesing, you add. Rule 2, if you're dividing, you subtract. So that's 3 to the power of 5 subtract 1, which is 3 to the power of 4. And again, it's the same if it's a letter. So I could have had y to the power of 10 divided by y to the power of 7. My answer would be y to the power of 10 subtract 7, which is y to the power of 3. Our third rule is different to the first two because it's not just adding or subtracting, unfortunately. It's where you have a power to the power of another power. So if we have 4 squared all to the power of 7, well, this time we do multiply those powers together. So this is the same as 4 to the power of 2 times 7. So this is 4 to the power of 14. And again, if you have letters, it works exactly the same. If I have a to the power of 3, and all of that is to the power of 5, then my answer is a to the power of 3 times 5, which is a to the power of 15. And the last rule is maybe the easiest one. It's that anything at all to the power of 0 is 1. So 95 to the power of 0 is 1. 3,421 to the power of 0 is 1. And again, doesn't even matter if you don't have a number. X to the power of 0 is 1. And so is y to the power of 0, because anything to the power of 0 is 1. So those are the rules. I have a few examples here that start putting them together and mixing them up. And if you're feeling brave, you can pause the video and have a go at those before I talk through the answers. Or if you prefer, you can just leave it playing so that I can show you how to work out or how to simplify those expressions using the laws of indices. So pause here if you want to, and I'm going to talk through the answers. So this first one is rule 1. Because these powers are multiplied, rule 1 says that we actually add them together because there's a multiply and our rule says we add them. So this is the same as x to the power of 3 plus 5, which is x to the power of 8. This question here is using rule 2 because it's a divide in there. So rule 2 says that if we're dividing, we subtract. So this answer is t to the power of 4 take away 3, which is the same as t to the power of 1, which you'd normally just write as t. And then we start having a mixture here because we've got some multiplying and divides here, so we're going to be using both rules 1 and 2. So let's simplify the top of this fraction first. We have p squared to the power of 2 multiplied by p to the power of 4, and rule 1 says that we add those powers together. So this turns into p to the power of 2 plus 4, so it's p to the power of 6 on top, divided by p to the power of 9. Remember that fraction is a divide, because now we know it's a divide, we can use rule 2, and if we're dividing, we subtract the powers, and our answer is going to be p to the power of 6 minus 9, which is p to the power of negative 3. That's the first time we've seen a negative power, actually. They are allowed, they are absolutely fine. You just treat them the same way as you do all the others. And our final example, a times a to the power of 4 divided by a to the power of 5. Well, this first a we've got here, don't forget, if there's no number there, it is to the power of 1. It's a bit like when you have x by itself, you know that it's 1x. You don't normally bother putting the 1 before it, because there is just one of it. It's a bit like that with the power. Now we can see the 1 there. We know that because of rule 1, we can add those powers together to turn it into a to the power of 5, which we are dividing by a to the power of 5. And rule 2 says that when we divide, we subtract. This is a to the power of 5 minus 5, which is a to the power of 0, which rule 4 says is 1. Anything to the power of 0 is 1. So those are the laws of indices, and there's a few examples there of how they work. There are 2 other laws of indices, but they don't come up nearly as often as these 4 do. So these 4 are the ones to try and nail, but you can, of course, look elsewhere for the other 2 rules and how they work. But that's it. That's the rules of indices. Hope that helps.